Hello, boys. Welcome back to our online classes. Um, I'm Jana Akhtar, your physics teacher, is with you again with review class. Before the Eid vacation, we were just trying to start our review class, and we have completed chapter 1 and chapter 2. Today we will just start from chapter 3 again. As your next exam is the pre-test exam, and the syllabus for this exam is your whole book, you have to review the all chapters again. So for that we had just started the review classes. I hope all of you are following classes and all of you are reviewing the chapters at your home. All of you are safe with the grace of Almighty Allah. I hope so. At this critical condition, being safe is the greatest blessing for us. So just try to stay at home and be safe. And now let's start our chapter. Chapter 3, force. This is an important chapter. In this chapter, the most important topics we will try to discuss that are the force, definition of force, the types of forces, different kinds of forces. We will try to focus on inertia, types of inertia. We will try to know the Newton's laws of motion. There are three laws of motion. We will try to learn or review that topics again. Then we will try to recall the topic conservation of momentum, conservation of laws of momentum, and friction. Friction is another important topic of this chapter. Different kinds of friction, frictional force. Sequentially, we will try to discuss all the topics that I have mentioned here. So let's start our discussion. As the chapter name depicts force, what is force? You know that force is a quantity. What kind of quantity? Force is the quantity, the application of which makes a stationary object moving and attains a moving body or object to change its velocity. So what is force? Force is the application of something, the application of something that taints a body to move or taints a moving body to change its current velocity. Force is a quantity. This is a derived quantity. All of you know that force is a derived quantity, and if we can categorize quantities in terms of scalars and vectors. You know that force is a vector quantity because before knowing about force we have to know about mass and acceleration. So this is derived quantity and this is a vector quantity because along with the magnitude the force has direction. So this is a derived scalar vector quantity as it has a specific direction. Then whenever we know about a quantity, we have to know is this derived quantity or fundamental quantity. We have to know is this a scalar quantity or vector quantity. We have to know the definition of that quantity. We have to know the units and dimensions of that quantity. Whenever in any chapter, whenever we just try to know about a new quantity, we have to know all this informations. So force, in terms of force, the unit of force is kg meter per second square, or in short it is called Newton. Then unit of force is Newton. SI unit is Newton or kg meter per second square, and the dimension of force is ml/t inverse 2. As all of you know, the equation or the measuring the value of equation, the value of force. For measuring the value of force, we have to know the equation F equals ma. From that equation we can determine the unit and dimension as well. The unit will be Newton and the dimension will be ml/t inverse 2. Next, we will try to recall the different kinds of forces. Before that, just have an idea about inertia. All of you know about inertia, the tendency of a body to maintain its present state forever is called its inertia. This is not a quantity or measurement. This is just a property, a specific property of an object, that an object just try to be at its present condition forever. That property is called inertia. Because of inertia, a body tries to maintain its own position always. We can categorize inertia in inertia of rest and inertia of motion. A very common example of inertia of rest is when a car at rest suddenly starts moving, we move backwards. That means when a car is just at rest position and suddenly it starts to move, then our lower portion of the body that is in direct contact with the cars that moves ahead, but our upper portion of the body try to remain at its own position due to inertia, so we move backwards. This is a common example of inertia of rest. On the contrary, inertia of motion, the example of inertia of motion is when a moving car suddenly becomes rest, we move forward. um, when a car is moving and suddenly it just breaks up, then we just move forward, because as the car was moving and it suddenly breaks up, our lower portion of the body that was in contact with the car that just stops instantly, but the upper portion of the body tries to go ahead because of its inertia, so we move forward. So these are examples of inertia of rest and inertia of motion. You have some other examples on your book, just try to have a look again. Next, we will try to recall the types of forces. We can categorize the types of forces in different category. If for applying force, we have to maintain direct contact with the object. Depending on that context, force can be differentiated as contact force and non-contact force. What is non-contact force? Contact force is that one where direct touching, direct connection, direct contact is necessary with the object. For example, to pull an object by touching it, it can be an example of contact force. On the other hand, non-contact force, where direct touching of the object is not necessary. Some examples are gravitation, electric force, magnetic force. These are non-contact force. Try to remember the examples for multiple choice questions. Then you have known about fundamental forces and its categories. There are 4 types of fundamental forces. What are fundamental forces? That forces don't depend on any other forces that are called fundamental forces. 4 types of fundamental forces are gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. Just let's have a look on the types of fundamental forces. At first, gravitational force. Then from the name we can guess that this is related to gravity. This is an attractive force between two objects. The attraction force between two objects is called gravitational force. This is a very weak force among all the fundamental forces. The next one is electromagnetic force. That means here electric force and magnetic force both are involved here, and combination of these two forces forms the electromagnetic force. this is the force between two moving charged particles. That this is electric force and magnetic force. So charged particles are necessary here, and at the same time we have to maintain the charged with its motion, or we have to confirm the force will act between two moving charges, because without moving charge we will not get the magnetic force. So the force between two moving charged particles is called electromagnetic force. This is stronger than the gravitational force, and this force can be attractive and repulsive. In gravitational force, we have known that this is an attractive force. This can't be repulsive, but the electromagnetic force is the only force which can be attractive and as well as can be repulsive. So try to remember this point. Is an important point. Then weak nuclear force. This is a nuclear force, that means it is involved with nucleus. This force is weaker than the electromagnetic force but stronger than the gravitational force. This force acts for very small distance, 10 inverse 8 meter, almost 10 inverse 8 meter distance. Within this distance, this force can act. Where we can see this force, the application of this force is on the beta ray emission. Whenever the beta ray is emitted by radioactive nucleus, and the reason of this is the reason of weak nuclear force. The beta ray emitted by radioactive nucleus due to the weak nuclear force. You have known about beta ray emission in your different discussion. Next one is strong nuclear force. This is a nuclear force, that means this is also involved with nucleus. This is the strongest one among all the fundamental forces, and this force is just acting between protons and electrons of nucleus. That means the force acting between protons and electrons of nucleus, as all of you know that in nucleus, protons and electrons are strongly bound together, and protons and electrons combinedly they just form the total nucleus. So the force acting between protons and neutrons of nucleus is the strong nuclear force, and this is the strongest force. So if we want to make a sequence of the forces in order to their strength, then what will be the strongest force? The strongest force will be strong nuclear force. The next one is electromagnetic force. The third one is weak nuclear force, and the weakest force of all these fundamental forces is gravitational force. You have to remember this point very clearly, because for multiple choice question, this is an important term. The sequence of forces according to their strength. According to their strength, the strongest force is strong nuclear force, and the weakest force is gravitational force. So I think you have known about all kinds of forces. You have read about these topics on earlier classes, but I'm just trying to make a review of all the topics. Then we can categorize the force in terms of balanced force and unbalanced force. What is balanced force? When two or more forces are applied on an object at the same time, and if the combined resultant force of the forces becomes zero, then what happens? Then the body remains stationary, though we are applying forces, but the body remains at its own position because the resultant force is zero, and the forces that we have applied here are called balanced force. And so the body will be the unbalanced force, just the opposite one of balanced force. When we are applying two or more forces on an object, if the resultant force is not zero, then the forces are unbalanced, because in terms of unbalanced force, as the resultant force is not zero, the object will move to a certain direction. That means the object will change its current position. It will not remain stationary, it will change its position, and the force is called here unbalanced force. So boys, in this class you have known about these topics earlier, but it is just a review. So you have known about force. What is force? According to chapter name, what is force? Types of forces. You have known about inertia. On our next classes, we will try to focus on Newton's laws of motion. We will try to recall the term momentum, the conservation laws of momentum, friction, and frictional force. These topics will be discussed on our next classes. Boys, just try to follow the class, and these chapters already been finished in your classes, so these are not new terms to you. Try to just recall the terms again, and more practice is necessary here. Try to practice the creative type questions more and more, and I think you will have a better preparation for your pre-test, test, and board exam. So boys, that's all for now. We will just continue our classes, and before our next classes, I hope you will just review the topics I have mentioned today. So boys, thanks again. Take care, stay safe.